We're going to start with the definition of conditions. Conditions is defined as the observational property of the system at a moment in time. Now, you've already been given this definition, so you should already have it in your notebook. But essentially, we are talking about when we have a state diagram, right? So we'll just do initial and final, even though we've been doing initial, middle, and final. And we have a person maybe swinging on a swing, okay? And then maybe they are now at the lowest point, right? So they're at the highest point. They're off the ground. Okay, maybe the strings on the swing are being stretched. And we're going to also apply that and look at the different conditions that are in the next page. Okay? So what you're going to do, or what we did in class, is use Post-it notes to write the conditions, one per sticky note, and we're just writing the conditions. We're not going to explain. And so some of the Post-its that you and your classmates had written were things like the hands turned red, something was on the ground, right? So hands turned red, maybe the hands were cold, something was on the ground, or maybe the ball was on the ground, and something was in the air, something was turning. The spring was stretched and then it flipped back to its original shape. Okay, so after this, I asked you all to go ahead and organize or categorize all the different conditions into separate categories. Okay, and so here are maybe an example of the categories that were chosen. Okay, so I want to bring your attention to shape change and what we ended up calling deformation. We also looked at location or position. We called things that were moving or not moving motion. And we also had something called temperature. And there was a huge argument in Block 6 about whether or not color was going to fall under temperature, but then we talked about color change. So the hands turning red was an indication that there was maybe some sort of temperature involved. Okay. And so when we list all these out, all right, so I'll just go ahead and list them. So we have movement or motion. Okay, so something like the ladybug was turning, the popper was flipping, the air moved or moved the ball off the glass bottle, and also the motion of not moving or staying still or at rest. These are all indications of motion words, right? So things that might be in motion or not in motion. All right, the next one we're going to talk about is shape or deformation. Okay, and where this is coming from is that when we look at these Post-its, right? So the popper stretched out to be inside out. We're deforming the popper to be inside out, okay? And then flipping back to its original shape. So we took its new form, which is inside out, and it flipped back to the inside state. And something inside the ladybug, right, was winding up. So there was like some sort of winding situation that was happening. And when the ball hit the floor, I think we talked about how the ball would kind of flatten out where it hit the floor. Okay. Excuse me. And then the spring, when it was stretched, because there was a mass hanging off of it. Okay, so here's the mass. The spring was stretched. And then when the airzuka, so the airzuka was pulled back, right? So the airzuka was pulled back and then something came out. All right, so there was something kind of being deformed the whole time. And so that shape deformation would be things like compressed, Okay, stretched. I think we're gonna, or squished. Okay, there's another one, squished. All right. So the next one we're going to talk about would be the location or the position of something. All right. So we had in the air and we had on the ground. So we also had like things moving across the state diagram, right? So back to our picture of this state diagram. Okay, so we had this person on the swing moving in that direction, and they were still continuing to move in the direction, which is to the right or to the left, depending on where you're facing. All right. But what we're also seeing is that that's a motion, right? So moving across would be the motion, and where the person was located from the ground, that's more the position that we're looking for, okay? So this is in relation to the ground. How far off the ground, I'm going to put this in quotes because the ground can be anything, is the item. And then the last grouping that most classes came up with was temperature. Okay. And so there was heat, there was cold, there was hot, and then block 6 really wanted to make sure that we included color change. Okay. Now also in block 6 there was another category, but I don't know if this is going to be on the test. But the idea of chemical energy, okay, or sorry, chemical conditions. We didn't really cover that in any of the stations we did, but the example that was brought up was about hair dye. Okay, so I'll keep it, but it's not something that all the classes came up with. Okay, so essentially, when we're going from one condition to another, so we have something that's compressed or something that's stretched, there's essentially a change in conditions. Okay, so there is a change in condition. And we call that change energy. Okay, and the energy is the ability to create change. Okay, and so we'll say to create change in conditions specifically. All right, and so we are going to notate energy using a big capital E. Okay, so all of the things that can create change is called energy. All right, and so now we're going to go to our different buckets of energy. So our first bucket of energy, okay, so our first bucket of energy will be movement or motion. So movement or motion can be derived from the word kinetic. So we will use the big E for energy and a subscript of little k for kinetic energy. So something that is being stretched or compressed, kind of like our hair tie, is going to be called elastic energy. Okay. Something that has a relationship to the ground, its position in relation to the ground, is going to be called gravitational energy. All right, and the last one, temperature, is we are going to call thermal energy. We don't call it ET because ET means total energy. So we reserve the E sub T for total energy. And these four are really what we're going to focus on in our modes of energy storage. Okay, so that would be the modes of energy storage. And what we're going to look at also is how the energy is changing. And so when the energy is changing from one type of energy to another, so like let's say there's a kinetic energy, and maybe there's a car, right? That's moving, and it moves off a cliff. Okay, and so now it is transferring, well, that's not actually a really good example. So we'll just have the car actually running into a wall, okay? And so what happens here is when the car runs into the wall, there's a lot of damage sustained, but also there's kind of like a heat change, right? So then what we'll say is that there is a thermal energy that is now present because of the kinetic energy and then transferring it into the wall. Okay. So the next part is, so let's just call it the transfer of energy. So you can transfer energy, and we'll call those transfer of energy changes. Okay. And so I know a lot of people in class were asking, what about potential energy? All right. And so we won't really call anything potential energy because all the different energies have the ability to become something else. So kinetic energy can be transferred into a different type of energy. And so because potential carries everyday meanings that mean a lot of different things, we're just going to go ahead and say not potential, right? So everything will just be energy storage, and we're going to store it in kinetic energy, or maybe something is being stored as a less elastic energy. Something else is being stored in gravitational energy. Something's being stored as thermal energy. Okay, and so we won't use the word potential because it's not really needed for when we're talking about energy as a storage. And so I know a lot of physics teachers use the word potential, but for us, we're not going to this time, and we're just going to keep it simple. So I know there are science books that say elastic potential energy, or a science book that says gravitational potential, but let's just go ahead and change it up. EG will be gravitational energy. Okay, so for this last part is going to be the activity 6 energy storage modes and transfer mechanisms. And so what I really wanted you to do was come up with your own example, and so your own example. So like, let's say my initial state diagram is I am on a diving board, right? And I'm going to be jumping into a pool of really, really nice and cool pool water. Okay, so there's my pool water, and there is, let's see, my diving board. There's the ladder. All right. Okay, so there's a diving board, and here I am on it. And then next, so make sure what you're going to do is keep your environment the same. So since I had a diving board, I'm also going to draw one in my final diagram. Okay, and so I'm no longer on the diving board, and now I am belly flopping into the water, right? So belly flop is what I'm looking at. Okay, so the changes in state would be that my position has changed. All right, so the position was, I was on the diving board, And now I ended up in the pool. Okay, and that occurred because I jumped. Okay, so I was on the diving board, so I had a lot of gravitational energy, so some EG, and then I jumped, which is EK, right? So there was some movement, and then now I'm in the pool. And so at first, my stomach, so there might be some thermal change as well. Okay, so my stomach might be fine, and then after I hit the water, it might turn a little red, right? So there's some heat transfer or heat absorbed, but there's definitely some thermal energy that is being shown when my skin color changed. Kind of like when we rubbed our hands were cold, and then we rubbed them, and then they were warm. All right, so the system schema would be, so let's say there's a teacher, okay, and the teacher was standing on top of, here, actually, I will go ahead and use a thinner pen. So your teacher was interacting with the diving board by standing on it. Okay, and then I jumped into the pool, so then there's some interaction with the pool as well. All right, and the ground here doesn't really matter because we're not hitting the ground, right? We're hitting the top of the pool, but Earth is definitely involved. So we need to make sure that Earth is connected to all the objects in our system. So our system schema needs a system boundary. Okay, so that's our system schema. And so you're just coming up with your own example. Okay. Now for energy. All right. So the definition of energy that we are going to be using is that the ability to cause change. Okay, so that's not exactly what energy means, but for right now, that's going to be good enough. And so that's how we are going to define energy. So the ability to cause change. All right, and then, and so energy can be stored and it can be transferred, right? So let's see, transferred maybe with 2 R's. Okay. So energy stored in movement is what we're going to call kinetic energy. And kinetic energy has EK as a symbol. All right, oh, and let's not forget our symbol for energy is going to be big E. All right, and so then our energy stored in position is going to be what we call gravitational energy. And that's going to be an EE. And deformation, remember, so deformation is going to be our shape change, and that is our elastic energy. Whoops, EE is here. And so gravitational energy is EG. All right, and then temperature will be what we call thermal energy. Okay, and that will be ETH. And we're going to reserve ET, right? So ET is going to mean total energy. So that's what we're reserving that one for. Okay, so just to recap, energy is, let's talk about how things are arranged in relation to each other versus just position, right? So we're talking about how things are moving, and that change in arrangement is going to be called energy. Okay, the transfer of something. All right, and now the important things to know. Well, energy is definition would be to the ability to create change. And the conditions is to recognize the presence of energy. So like the condition of motion, which is actually kinetic energy, and the conditions that are related to deformation. So that's our shape, and that's going to be elastic. And our conditions of position in relation to Earth or the ground, we're going to call that gravitational energy. And conditions, anything that's relating to temperature, is going to be thermal energy. All right, so now that's really it. Okay,